Okay, so to graph the key features of a quadratic, the very first thing you should probably go for is to go ahead and get your roots. So I notice here that I can do GCF. So I take out a 4 and I get x squared plus 5x plus 6. And then I go ahead and I factor the rest of it. And 6 could give me 6 and 1 or 3 and 2. And I see that 3 and 2 have to happen because it's 2 pluses. So to solve for my roots, I have 4 equals 0, which we know does not work. It's not a true statement. Then I have x plus 2 equals 0 and x plus 3 equals 0. So therefore my roots are x equals -2 and x equals -3. And I would box those in. Then I'm going to list my ABC. And my A is 4, my B is 20, and my C is 24. I need to make sure that it's in standard form when I do that. Then I'm going to go ahead and do -b over 2a, which is -20 over 2 times 4, which gives me -20 over 8, which simplifies to -2.5. That is my axis of symmetry. Now I need my vertex, and I know that my axis of symmetry is the first coordinate in my coordinate pair for the vertex. So I write that in, and then I take that x and I plug it back into the standard form to get the y. So I'm going to do that right below so that you can see it how it's plugged in. And if you use parentheses like I've been teaching you, you're going to have less mistakes. So this becomes 25 plus -50 plus 24, which is a -25 plus 24. So that's going to equal -1. So I'll go back up here and I'll put -1 as my y value for the vertex. Then I'm going to choose my y-intercept, which is my C in standard form. Then I'm going to look at my A and see that it is positive, so my graph will be up. And then I'm going to start to graph it. And that'll tell me if I need arbitrary numbers. I need at least 5 points on the graph. If I can get 5 points on this graph without having to do arbitrary, then I don't need to do it. So the first thing I'm going to graph is my vertex, which is -2.5, -1. 1, 2.5, -1. There's my vertex, and I'm going to label it. And I know that that is also the line that my axis of symmetry goes through. So I'll put a dotted dashed line down the vertex, and I'll label that axis. Then I'm going to do my roots, which are -2, -3. 1, 2, 3. 1, 2. I can tell it's in the middle. That's 3 dots. But I also have my y-intercept, which is 24. And I'm going to count by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. And since that is here, then I know that there's one on the opposite side. So that means I count 1, 2, 2.5. There's a half, 1, 2, and I can put it right there. Now, how many dots did I get off of that? 1, 2, 3, 4, 5. So I don't need to do arbitrary numbers on this. So this is my y-intercept. This is a root, and this is a root. So this example does not need arbitrary numbers. And I'm okay with it being this skinny because my A is a 4. And that's greater than 1 whole number. So it's going to get skinnier as the whole number gets larger.